Okay, so question number 10. Draw the Lewis dot structure for SO2 and all of its resonance structures. So first, let's calculate the total number of valence electrons for this compound. So the number of valence electrons in sulfur is 6. And for oxygen, it is also 6. And we need to multiply this by 2 since there are 2 oxygen atoms in the compound. So in total, we have 18 valence electrons. So let's try to draw a Lewis structure for this compound. We have sulfur as our central atom since it is less electronegative than our oxygen. And we can draw 2 single bonds to the oxygens. So notice that none of them have a full octet yet. So if we drew these as double bonds and filled in the lone pairs on oxygen, we can count out how many electrons I've drawn so far. So each bond contains 2 bonding electrons. And we have 4 bonds, so that's 8, and each oxygen atom has 4 electrons as lone pairs. So we only have 16 out of the 18 electrons drawn in this molecule. So we can write the remaining 4 on our sulfur atom. But this isn't the only Lewis dot structure, because the question also asks for all of the resonance structures as well. So in showing the resonance structure, we can show how this pair of electrons can come down to form a triple bond, forcing these electrons in the double bond to go onto the oxygen to form a single bond. So another resonance structure would be a triple bonded oxygen to the sulfur and another single bond to the other oxygen. So this oxygen now has 2 electrons as the lone pair, and this oxygen has 6. And we can also draw another Lewis structure like this, or another resonance structure. If we were to switch where the triple bond and the single bond is. Okay, so we can also have these 2. And if we calculated the formal charge of these atoms, so formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So first, let's calculate the formal charge of an oxygen that has the double bond, like in the first structure. So oxygen has 6 valence electrons, and the double bonded oxygen has 4 non-bonding electrons, and there's 2 bonds to it, so we have 4 bonding electrons in total divided by 2. So a double bonded oxygen has a formal charge of 0. If the oxygen had a single bond, it still has 6 valence electrons, but this time there are 6 non-bonding electrons, and there's only the single bond, so there are 2 bonding electrons divided by 2. So all of the single bonded oxygens would have a negative charge. And we can also calculate the formal charge of a triple bonded oxygen. So again, there are 6 valence electrons. There are only 2 non-bonding electrons, and there are 3 bonds to the oxygen. So we have 6 bonding electrons divided by 2. So 6 minus 2 minus 3 is positive 1. So therefore, these 2 oxygens, so the oxygens with the triple bond would have a positive charge. So these are our different resonance structures for sulfur dioxide. And the junior tutor said the same thing. So this solution is correct.